Good afternoon. Thank you for being here. I know that this Friday afternoon, you want to go to the sun, the beach, but today I want to share with you some experience about projects where we mix services and microservices that have the approach of to be asynchronous or not, or to be reactive or not, and some challenge that we handle on these kind of situations. So I'm Alberto Salazar. I mainly work in the community and in around Java Enterprise world in the last 24 years. So I am here almost from the beginning. I also write some code for the application service that many people use in the world, like JBoss, Tomcat, and some libraries that in the beginning of the REST world, I start to maintain and give and share to the world. And the mainly skill that I have is that I always being in the production side and in the whole software development life cycle in the application. So where I learn is when I put in production what you create, and then everything burns. So since the beginning of that I've been working on the Java Enterprise world, when in 2000 we were only 2 million developers, Java developers, and now we are around 8 million Java developers. And in other language, we are now like in the world 28.5 million developers. So I'm being here before DevOps, before the practice that we now are having, before we start to split teams. When we create the first Java Enterprise applications, we created, we tested, we put it in productions, and we see how everything burns. So let's start with this talk. Before we go to the troubles, let's understand what we are talking about when it's not a reactive application in the Java world. It's around like 85% of services and microservices that now are running in Spring Boot and Spring Framework. And the non-reactive stack of technology is when you use controllers and REST services as with the Spring MVC. We always, in the enterprise world, get data. So we use Spring data. And we always, almost in all enterprise applications, have a database or a queue or some place where we want to leave the data or take the data. In this example, for the code that I'm going to leave you in the end, I use for the demo purpose H2. And also, when we embrace the enterprise Java applications in huge institutions, I mainly work in the banking industry. So I work for banks in almost all countries in Latin America. I have customers in all of them. I work for US. I've been working also to Australia and Switzerland, and for houses to create digital platforms on the banking industry too. So when we arrive, or like me, I work for banks and I arrive for see the problems that they have. Almost all of them have some applications that they continue running in the old-fashioned or traditional way. So they are running an application server, they expose services that are non-reactive, and also they are creating new stuffs with the stack that I told you about, the Spring and Spring Boot. And what is happening with this kind of applications? Like we know, or EU don't know, all of them work in a blocking perspective. It's like when I want to say the REST services, please bring me the customers. So what is going to happen in the server is going to block one thread, and then what is happening with the second thread is, I need some data. So they take another thread to create the query and the JPA data. And then if we have logic inside, they start to use more threads. Until, why? until when? Until I finish to respond the whole data who were asking me the service. So I take all the time, I block some threads. Yes, this happens in milliseconds, but with concurrency, we start to use more and more threads. This is happening with all these traditional applications and non-blocking applications. And in 1 year or sometime, this changed. He said, okay, we have now Webflux. Why I don't try this? Why I don't try a reactive service? So several teams start to create a different approach. What was this approach? That they think that they are doing non-blocking applications, but they don't realize that they continue having services that are blocking. They think that the new services is going to be asynchronous, event driven. And what is the main characteristic that this kind of reactive stack of Webflux have is that they use less threads. In one concept, the concept is that I'm going to subscribe. So who are going to get the data is going to say, hey, I need the customers again, but they are not doing a request response. What is happening inside the container or inside the code that is writing in Webflux and in another container that is named Netty or in Servlet 3.1 that also support reactive is that you subscribe, so the client subscribe. Inside the container, what's going to happen is going to be one ID that is set in a map main memory that says, okay, this client have this subscription, okay, I'm going to take one thread, and then I'm going to reserve this and continue working. Then I go to the database, and if the database changes the data, it's going to send the events or the event to the client or to the application that is asking me about the request or the data. So what is happening with these threads is like we have an event loop inside the container, and with a small time of the blocking the thread is going to make a call. So he is going to use less threads. This is going to happen with the Webflux application. And in non-blocking way, he starts to process it. So he take a little bit time, use less threads in the application, and have a concept that is really important when we work in reactive applications with Webflux, that is a back pressure. I can use back pressure or no? Back pressure is that I can send data by parts. So in real time, I can send them what the client or the client can set, can handle all the data, so he is going to take a little bit by 1,000, by 100 in real time. This is what is going to look the threads inside a Webflux application. But it's different to have the approach of reactive programming that I am just explaining you than the reactive system. So the most customers that I visit in this kind of banks, they are not taking or they are not approaching the reactive system. So they are going to mix these blocking service and non-blocking services. To make a point of this, a reactive system has some principles and more vision around the whole system, that it must have 4 principles. That this must be responsive, resilient, it must be message-driven, and elastic. But for make things like this is the whole system. So I need to take care for the whole architecture. So maybe I can have these kind of systems in one part of the enterprise banking applications, but the whole application will never change. I continue making calls to COBOL core banking systems. I continue having the applications, like I said, in Java Enterprise Edition in application server that running as a blocking application. So this is going to embrace several problems because we are taking 2 different perspectives. We are taking most care of the perspective that is just the programming perspective, So it is a single point of view of a single service that is going to be handle as scene data, and this is an implementation technique. But we are not taking care of the whole system. So this is what is happening with the problem. And this is the big problem that we have in this kind of situations of mixing reactive and non-reactive services. And let me ask you something. I arrived in around 20 banks in the last 5 and 7 years and asked why you use Webflux. And what do you think is the response? Somebody can say it. Why they are using Webflux or reactive services? Somebody? Nobody? Nobody wants to answer? They want to play with tools is the answer from there. The mostly answer that I have from each of these teams of architects, engineering teams, I'm thinking about customers that have 1,000 developers, 500 developers. The small one has 100 developers. So it's big teams. They want to scale. They want to create microservices. And the answer that they start to use Webflux, it was because it's fast, and I'm going to use less resources. But today, we're going to show you two simple applications that is reactive and non-reactive, and let's see what is the results of using the two of them. The example that I'm going to use now is in the same perspective, a simple application that's going to give me customers, is going to have two different stacks of technology. A Spring MVC, Spring Data, H2 database, and in the reactive stack is going to be a Spring Reactive Web, that is Webflux, over Netty, and I'm going to use Spring Data to DBC, and the H2 database too. So the application is going to look almost the same. Even a lot of them are working on migrating to Webflux because they think that it's going to work fast and going to respond fast and going to save money in the cloud or in the resources that I'm using. The application is looked really simple for the first example. So I have an API that is going to expose 3 methods. It's going to save and going to get the data. In the reactive way, what is happening with what is wrapping all the data? When you work with Webflux, how many of you work with Webflux or make an example of Webflux? 25%, less than 25%, 20%, 15%. When you use Webflux and you have 2 wrappers that is going to name Flux and Mono. Mono is used when the data pipeline is going to be just one time call it, and Flux is that I'm going to giving several data in several times. It's like a wrapper for the object. So what you are going to see when you find these kind of applications, you have always working with Mono and Flux. And in the blocking or the traditional way, it's just the object that I send a list of objects or I send one object. In the repository part, you almost look the same. So the repository, what is going to be the difference in Spring application is that the reactive is going to be on the stack of the reactive CRUD repository. It's almost look the same. And I'm going to get a flux of data from the database. And on the traditional way, it's almost the same, but it's a JPA repository that's going to find the same. On the mapping of the table or the data using JPA is with an entity annotation, but it's the same. It's just a simple example. In the reactive way is going to look the same, but it's just a table with it's not an JPA annotation. It's going to be a notation of just I'm using data for Lombo, and the table is going to be from the Spring stack of the reactive way. What happens if I run these two applications and send a lot of data? What do you think? You think it's going to work better the non-traditional, the blocking application or the reactive non-blocking application? How many you think that is going to work better one from another? Nobody wants to answer. Better the non-reactive application. Raise your hand. 2, 3, 4, 5, 7. Okay. Just let's look at it. I have running these two applications there, so I'm going to open a JConsole. I'm going to attach the reactive thread of the JVM. Just give it a second. I'm going to attach again. Let me check it. Two are running. So I'm going to take again the customer and secure connection. Okay. And I'm going to open another JConsole. I'm going to attach another thread on the JVM. It's going to be the traditional application. So just let's put the two of those applications here. Oh, this one is not attached. I'm going to stop the thread application and run again. That one is the traditional, and that one is not. So it's started again. Okay, I'm going to close that one. That one is running. I'm going to start another one. I'm going to take the reactive application here and secure connection. Okay, you're right. So just let's through 1,000 concurring threads and sending data to the services. So one is running in 8080, one is running in 8090, and I'm just going to throw several data. So just send 1,000 requests in 2 threads to 9090, and I'm going to send the same, but to the 8080. What happened with these two kind of applications? What you are going to see is that the memory footprint of the application is almost the same. We have in the left the reactive, we have in the right the non-reactive applications. What is the difference between one and another one? Is the threads. I'm going to send more data to the services. I'm going to analyze that. So I'm going to send more to that one, more to that one, and more to also to the reactive way. What did just happen with the two of them? Almost nothing in this kind of situation. Only if I start to make more calls to the non-reactive. I'm going to try now 1,000 calls. So I'm going to change this. I'm going to be 10,000, 10,000. For the 8080 that I want. customer traditional, non-traditional. I'm going to see just the threads. This is the real difference, okay? Is that in the non-reactive, the application is going to be around 20 to 30 threads almost all the time. Almost all the time is going to happen this. In the servlet blocking application, is going to handle between 30 to 200, or if I change the parameter, it's going to have more. But let's realize 200 threads in virtual machines is the real ones that is going to handle even Apache or the web servers that is going to handle. This is the only difference. But in CPU, you don't change almost nothing. In RAM, you are not going to change nothing. So in real life, if you want to save resources, what do you think that is the answer of that? It's going to save you resources on the cloud if you are working on microservices and containers? How many of you think that the resources is going to save? The reactive is going to save you. A lot or not a lot? In real life, no. It's almost the same. Just check this Kubernetes statistics of a real application. Like the application has the same memory, use micro CPUs, that is containers on a Kubernetes. The reactive and non-reactive use of threads is represented on CPU use. But in the real world, it's almost the same. So if I make this perspective to see just the threads between 200 and 330 to 200, I said, oh, okay. I take the decision. I move forward to Webflux. But the answer is maybe no. You can continue creating the same service, and if you run the same application in Kubernetes or OpenShift, this is a statistic of OpenShift in a banking application that runs around or serves around 3 million people around each day. So it has 1 million logins a day. Is a retail banking application. The use of the CPUs, you see, between reactive and non-reactive is almost the same. The micro CPUs is almost the same use. So the answer of the use of Webflux, because it's going to save me resources, is a takeaway. Is no. It's not the answer. What other things happen with these kind of reactive services? They start to use, because of mix in these huge environments of a lot of developers, they have a lot of teams. And what happened between the teams? So some of them are working on Webflux and reactive, some of them are continue maintenance these applications that are running in application server, and another groups of people are working on Spring MVC. What starts happening in the problems where they use or mix these services? They start to have a lot of troubles on which team has the problem. The problem was, no, my application now runs with less resources and can handle millions of messages because it's reactive. The another team is, no, it's your problem. And how we realize this kind of situation in applications that has 1 million lines of code, 2 million lines of code. So we need to start to try to find the troubles, because they start to have an enterprise application that in this kind of industry that I work is complex. So they have reactive services, they have non-reactive services, they have several event streamings, like Kafka, Azure Event Streaming. They have several kind of databases. They also have core banking systems that are running in BASIC, in COBOL. So with all this mix, the saving part is not going to be the reactive stack of the microservices. And let's see some real code that the teams that create this kind of application are running. Let's take a look of these 4 methods. The 15% of people that were working on Webflux can say me what they see wrong about this code. Somebody? Block. Yes. What is going to happen when somebody is doing this method in a reactive data flow? Somebody knows? Asynchronous again, and it's going to block the thread until it's finished. Great. So the problem in a lot of this code that we find is that a lot of work on the business layer of this logic is working, or the people is working using the block method. And this is the reality. Even if you put the rule that you must not use it, they are using. And in this kind of situation is, if you arrive or somebody arrives, said, why? Why they are using it? There must be an explanation that they are using it. And this situation, it was that try to find the code, what is happening. Why this is happening inside. So let's take a look at this real world class. They start to call all these 4 methods from another one. They try to make logic on the pipeline that is going to take data from the database in different parts. And even in this method, what is happening in the end that I'm going to show you later is that they are subscribing. For you understand, the people that don't work on Webflux or don't work on reactive data pipeline of application, what is happening when you start to work on Webflux, or you change your mind to work with Webflux? You have a single line of time with your data. So if somebody said, please give me this customer that I showed you in the beginning, that is an event, and somebody is subscribing to them, and in the code that you say, see, the operator is that I am processing the data, so I am enrichment the data with the logic, or I am splitting the data, or I put logic in the data, is what is called the operators. And what is going out of my data is in the same line of time. When I do block, what is happening? I stop to nobody. I stop the timeline of the data streaming. So I block the data and start to create another one. And when you read the code, in the end of the method, they subscribe. Even they are blocking, they are subscribing. In the reactive way, you subscribe for the data to end the timeline. So I create this business method that I showed in the real life that is hard to read, that has a lot of block codes, and then in the end they subscribe because they are finishing the data. So the first thing that we must do in this kind of code is to understand why they are taking these decisions. And they were taking this decision because it was a spaghetti code. That you can have this in reactive and in a non-reactive way. But in this kind of application, everything is stuck. They start to, in this application, they load the payrolls or the several payment services in files, 10,000, 20,000, 100,000, to run in the application. And in the code, what is happening is that they start to save states in the database. And this is why they are using block, because if they don't put block in the method, the data is not in the database. Because in the reactive pipeline, everything continues running, and when the subscribes finish, that is the end of the method, he recently starts to say everything. But they try to work in a spaghetti code that most of the developers are accustomed, because we are accustomed on request response, nothing happened. So I go to the database in the Spring repository or in the business layer using the Aruba service annotation, and I take 3 tables, like everything is one part. I always have the 2-phase commit, so I have the data to running to work with. So they do that because of this. So what we start to do, or what we need to take away, first, if you use reactive and Webflux, it's not for the performance or resources. Second, don't use block in your business logic and try to understand why they are using it. Because in the beginning of these situations, we start to ask why they are using it. They said, because we start losing data. And that was also one reason they start to put block. So like my data is not saved, I use the block method. So I try to take away the block method. But if I take out the block method, what I have in the right part of my side is with mono, in the left part, the methods that I don't need, that must be in the same data pipeline, I take away the block method. What is the other trouble that you handle when you are running these applications and productions? Raise an error. The stack trace, when you are using the stack trace of a exception, when you are using a non-blocking application on the servlet, that everything's running in a servlet in a web container, is giving you in the stack trace the method and the class that has the trouble. If you are looking for production logs, this happened to you. But when you are working with data pipelines, what you see is just the stack trace of Reactor or Flux or Mono. And it's really difficult to find an error. It's really difficult to realize what is happening with your application. So you start to be, what happened here? What is happening with my application? I don't know what is the error. What is the business logic of the error? So one approach to fix this, or what we do in this application that were already made, already built, and the code that we already have, is to start to handle global errors. How? In the REST or in the top layer of the applications. So we start to, if you see the code, extends the web client part, and everybody who are using must extend a base request or a base class. And I always take what happened in the mono and start to do it what they don't do in the data pipeline. This is just for safe or to show the errors to the client side of the application. Is who asking me the data or who is subscribing my data. It's a simple way, but it saves us a lot of time. So, to finalize and understand these 3 key takeaways. There are more, but the talk is just for 40 minutes. And is that we must understand why we want to use Webflux, or why we want to move to our reactive applications. Is really work if you are going to make, like in the external server calls, the API gateway of Spring is based in Webflux. Now there are a new version of based in servlets that is working almost the same. But if you are going to work with an API gateway, the Spring Cloud API gateway is based in Reactive. But you don't see all this kind of code. It's just take the call and come back. The call to the service and come back. For this, is really work the reactive way. Real-time data streaming. So, if you have an application, like you are going to show stocks, or you are going to monitoring something, and you are going to attach data with an event, if you can create and use a reactive service, it's going to work really well, and you're going to send data whenever you need, that is subscribed. But the whole stack must be reactive. If you have in this data pipeline of data streaming one block or one mix of non-reactive services, it's going to happen the same. The team is going to say you, my data is not coming, or it's coming not in the time that I want, so it doesn't work. So for UI, when you want to work with real-time data from the UI part, from the mobile part of the application, is really working. So, some learnings to go to some questions of you. First one, you are going to create a reactive system. It's going to run great, but it's going to take care of the whole reactive architecture. So it's going to be a reactive system that is different than just create a service that is reactive. It's different kind of perspective. Like I showed you, the two parts of code almost looks the same, just have this wrapper mon on Flux, but the difference is that you must work in the data pipeline. This has several complexity. Not all of the people understand this data pipeline that I'm going to run in the same way, that I ask the data until it comes back. Everything must flow and be magic. Saving resources, if you are working on Kubernetes, cloud, or in application servers that running on the cloud, nothing is going to happen. You can create the microservices with the Spring MVC versus the Spring Webflux that in containers and in cloud is going to use the same micro CPUs and the same memory and almost the same footprint of the size of the image. If you were here at 2 p.m., it was a trade-offs to create a small image using JDEBs and JLink. But if not, the imaging is going to be the same size, nothing happened. The trace error on this kind of reactive services is really hard. It's really, really hard. You're going to suffer if you don't make good logging and handle the errors or each data pipeline. Like in all kind of architectural system, there are not a fixed recipe. You need to try, fail, and then win. These little examples are in repo. If you follow me Twitter, I'm going to share the same slides here. They also are on my GitHub account that is LA Salazar. I have some articles of Spring Webflux and simple samples in Spanish and in English. And I also have a book that is about the Spring 5, but now I'm thinking to writing Spring Framework 6. And that's all that I have prepared for you today. And if you have any questions or any doubts, just we have some minutes to it. No? No questions? Okay.
Hello, thanks. Regarding resource, if you have many more threads, you at least need more heap memory for them, right?
I don't understand the question.
You said that reactive versus non-reactive, you were comparing the resources. You said CPU, it's the same, memory, it's the same. But if you have more threads, this means more memory is used, right? At least for the heap memory of the threads.
Yes, but if you are using containers and you are running in a Kubernetes environment, working on microservices, you always are working on small footprints and small. You always put a limit. The resources are not infinite, and in the Java application stack, is going to be the same that you have the one or the another one. Just if you have an on-premise environment, maybe it's going to work for you. But the problems that you are going to bring is more than the solutions that you want to have.
Okay, thanks.
What you need to understand is that when you are working on Kubernetes and microservices, you are running on micro CPUs. And in the infrastructure that you are using, are limit that you put on the 60% of requests or the requests that can handle the same resources. In the situation that you are going to mix services, it's not going to help you. But if you are going to have one microservice that's full reactive, and you are going to use the whole reactive stack to subscribe the data, it's going to work for you. But if you mix this kind of enterprise applications that have reactive and non-reactive, it's not worth it, the saving resources. We're okay. Thank you for being here. Or if you have any questions more. Happy to be here. Happy Friday for you.